Welcome to EPG Pathshala. Students, today we are going to discuss on hydropower as an energy source. Hydropower, the energy produced from the motion of water. That is, this type of energy can be produced from water which is flowing or falling. Hydropower energy, the estimated potential in India is around 1,48,000 megawatt. This is from small hydropower plants and large hydropower plants. Mainly in remote rural areas, the electricity generation depend on the small hydropower plants. It is a renewable energy source and depends on the solar energy for its production. Here, the water in motion turn the turbines, in turn turns the generator, produces the energy, electricity. Hydropower is used for electricity production as well as the other purposes for drinking, irrigation, etc. In this module, we will be looking into the hydropower potential, how it is calculated, the principle of hydropower plant or the operation of the hydropower plant or how it is produced, how to classify the hydropower plant based on different criteria, what are the factors affecting the energy efficiency or energy production in hydropower plants. We will also see what are the components of hydropower plants and the different types and the benefits of hydropower plant along with its disadvantages. As well as we will see the hydropower potential mainly focusing on Indian context. The word hydro derived from Greek word and it means water. So, hydropower is the energy contained in water, that is the electricity or the energy produced from water is denoted as hydropower. It is a renewable energy source where power is derived from the energy of water using its gravitational force when it is flowing or falling. Let us see what is the principle of generation of hydropower. The water in motion has kinetic, that is moving energy. When flowing water turns blades in a turbine, the form is changed to mechanical energy. The turbine turns the generator, a rotor, which then converts this mechanical energy into another form, that is electricity. So, in this hydropower generation, the water in motion, that is the kinetic energy, convert to mechanical energy, further this mechanical energy convert to electrical energy. So, hydroelectric power is generated by the flow of water through turbine, turning blades of turbine, generator, finally producing the electricity. Since water is the initial source, we call this as hydroelectric power or hydropower. Let us see how to estimate hydropower potential. It is estimated by equation power equals Q multiplied by H multiplied by 9.81 eta. P in kilowatt, which is the power, Q is the discharge in cubic meter per second, H is the head in meters, eta is the overall efficiency. This efficiency is from the turbine, generator and gearbox. Normally 75% is considered as eta value. The head is relatively constant in run-off river schemes except for variation in friction losses with varying discharge. In irrigation canal or dam to base scheme, head also vary depending on season of release of water as water level in the dam varies throughout the year. Weighted average is found out to design the head of the turbine. Design head is so selected that turbine is operated to maximum time giving optimum energy generation. And the energy per year is calculated as E is equal to P multiplied with time. Time in hours, that is 8760 per year, and the unit is kilowatt hour. For the run-off river hydropower scheme, it is useful to know the variation of flow over the year to select the most appropriate turbine configuration and estimated power generation. Flow variation presented in the form of a flow duration curve is most useful form. The firm power and secondary power could be easily estimated from the flow duration curve. Let us see the global scenario of hydroelectric power. The world's first hydroelectric power or the plant installed in 1882 at Appleton, USA. These are the major 10 countries which are leading in the hydroelectric power generation, and India ranks 7th position among these. Let's see a brief history of hydropower generation in India. The first hydroelectric installation in India was in the Darjeeling Hills, that is at Sidrapong, in 1897 with a capacity of 130 kilowatt, followed by Sivasamudram project in Mysore district of Karnataka in 1902. Also, Mohra, Galoghi, Jammu, Karteri, Pullivasal, Jubbal, Chabba are other non-small hydropower stations, and still they are working. These plants are mainly or the primarily used for the lighting purpose in most of these towns. Bakra, Rihan, Hirakud, Periyar, Koina, Saravadi and Machkund are some large hydropower projects executed in earlier days in India. In India, hydropower contributes about 15.37% from large hydro and small hydropower. The estimated hydropower potential of India is 1,48,701 megawatt. Additional 6,780 megawatt are from smaller hydro schemes. Small hydropower projects are up to 25 megawatt capacity. The estimated potential of this SHPs, that is small hydropower plants, are 20,000 megawatt, of which only the 4,341 is harnessed. The public sector accounts 92.5% of India's hydroelectric power production. Some of the public sector companies producing hydroelectric power in India are NHPC, National Hydroelectric Power Corporation, Northern Electric Power Company, NIPCO, Satluj Jal Vidyut Nigam, THDC Tyri, Hydro Development Corporation, NTPC Hydro, etc. The ministries dealing with the hydropower are Ministry of Power, which are looking into the large hydropower projects, while Ministry of New and Renewable Energy is responsible for the small hydro projects. Alternate Hydro Energy Center at IIT Roorkee was established in 1982 with the sponsorship of MNRE to help in the technical and HRD of the country. Ministry is aiming at least 50% potential of the country hydropower to be harnessed in the next 10 years. This map shows the hydropower plants in India. You can see the major one, the most of the potential is in the Himalayan state, as the river based projects and other states on the irrigation canals. You can see the capacity of various hydropower plants along with its location in this table. Let's see the components of hydropower plants. Major components of hydropower plants are dam, water reservoir, penstock, intake or control gates, powerhouse, turbines and generator. Dam is the most important component of hydroelectric power plant. It's built on large river which has abundant quantity of water throughout the year. It should be built on a location where height of the river is sufficient to get maximum possible potential energy from water. Next component is the water reservoir, the place behind the dam where water is stored. Water in the reservoir is located higher than the rest of the dam structure. Height of water in the reservoir decides how much potential energy the water possesses. Higher the height of water, more will be the potential energy. The high position of water in the reservoir also enables it to move downwards effortlessly. The height of water in the reservoir is higher than the natural height of water flowing in the water, so it is considered to have an altered equilibrium. This also helps to increase overall potential energy of water, which helps ultimately produce more electricity in the power generation unit. Intake or control gates. These are the gates built inside the dam. Water from reservoir is released and controlled through these gates. These are called inlet gates because water enters the power generation unit through these gates. When the control gates are opened, the water flows due to gravity through the penstock and towards the turbine. The water flowing through the gates possesses potential as well as kinetic energy. Penstock is the long pipe or the shaft that carries the water flowing from the reservoir towards the power generation unit, and it comprised of turbines and generator. The water in the penstock possesses kinetic energy due to its motion and potential energy due to its height. The total amount of power generated in the hydroelectric power plant depends on height of water reservoir and amount of water flowing through the penstock. The amount of water flowing through penstock is controlled by control gates. So, a hydropower plant comprises civil components and hydroelectric components with hydromechanical and hydroelectrical equipments. Let's see these parts in detail. Diversion structure or reservoir. We have already seen some of the function of reservoir. The function of diversion structure is to divert the water required for power generation to the sedimentation tank through feeder channel, whereas the function of reservoir is to store the water from surplus period to deficient period. Reservoir or diversion structure may be built on surface. Structure design should be safe against sliding, overturning, etc. Desilting device. For run-off river type schemes, desilting devices are provided in the water conductor system, as diverted water carries sediments as may damage the turbine parts, penstock and other components due to abrasion. In the desilting devices, the incoming velocity of water is lowered by increasing the cross-sectional area of desilting device, thereby effectively allowing the sediment of particle. Power channel is the one which carries water from source to forebay tank. The main function of this channel is for water conveyance and also to sometimes take the surge of water. The power channel may be lined with concrete to prevent the loss of water due to seepage. The shape of power channel may be rectangular or trapezoidal. The forebay is a small storage pond located in between power channel and penstocks. It provides immediate water demand on starting the generating units and required water seal over the penstock inlet against air entrainment. Surge tank is the storage with possibility of allowing the surge to move up and down without causing any penstock. Suitable spillway is provided on one side of forebay to dispose of safely the excess inflows during load rejection. Penstock, the pressure conduits carrying water from forebay or surge tank to the powerhouse are termed as penstock. These are required to bear maximum water pressure including water hammer which occurs due to sudden closure of inlet valve. They are quite costly and important part of a water conductor system. Normally this is made up of steel, glass fiber, reinforced plastic or concrete. The functions of powerhouse are to support and house the generating units and their accessories against weather and other human activities. It can be of surface type or underground type. Tail raise channel. After passing through the turbine, the water is discharged back into the stream through a short channel called tail raise. The tail raise channel is to be designed such a way that minimum tail water level is required to maintain safe suction head for smooth operation of the turbine. Let us see the hydromechanical equipment. It comprises of hydro turbine, gearbox and gates and valves. Hydro turbine is a fluid machine used for converting hydro potential available in water into mechanical power and then utilize this power for driving the electric generator in power plant. Water flowing from penstock is allowed to enter power generation unit which houses turbine and generator. When water falls on the blades of the turbine, the kinetic and potential energy of water is converted into rotational motion of the blades of the turbine. The rotating blades causes the shaft of the turbine also to rotate. The turbine shaft is enclosed inside the generator. In most hydroelectric power plant, there is more than one power generation unit. There is large difference in height between the level of turbine and level of water in the reservoir. This difference in height is known as head of the water and it decides the total amount of power that can be generated in the hydroelectric power plant. Turbines can be either reaction or impulse type. The turbine types indicates the manner in which the water causes the turbine runner to rotate. The reaction turbine operates with their runners fully flooded and develops torque because of reaction of water pressure against runner blades. Reaction turbines are classified as Francis or mixed flow and axial flow. Axial flow turbines are available with both fixed blades, that is propeller, and variable pitch blade, that is caplant. Both axial flow and Francis turbines may be mounted either horizontally or vertically. Impulse turbines, it operates with their runner in air and convert the water's pressure energy into kinetic energy of a jet that impinges onto the runner buckets to develop torque. Pelton turbines, turbo wheel, Tross flow are some of the examples of impulse turbine. Speed governor is a combination of devices and mechanisms which detect speed deviation and convert it into a change in servo motor position. A speed sensing element detects the deviation from the set point. This deviation signal is converted and amplified to excite an actuator, the hydraulic or electric, that controls the water flow to the turbine. In a Francis turbine where there is reduction in water flow needed to rotate the wicket gates, a powerful governor is required to overcome hydraulic and frictional forces and to maintain wicket gates in partially closed position or to close them completely. Speed increases when the turbine and generator operate at the same speed and can be placed so that their shafts are in line. Direct coupling is the right solution. No power losses are incurred and maintenance is minimal. In many instances, particularly in low head scheme, turbine run at less than 400 rpm, requiring a speed increaser to meet 750 to 1000 rpm of standard alternators. In the range of powers contemplated in small hydro scheme, this solution is often more economical than the custom made alternator. Let us see the hydroelectrical equipment. It comprises of electrical generator, transformers, circuit breakers and relays. Generator is the one where the electricity is produced. The shaft of the water turbine rotates in the generator, which produces AC, the alternating current in the coil of the generator. It is the rotation of the shaft inside the generator which produces magnetic field, which is converted into electricity by electromagnetic field induction. Hence, the rotation of the shaft of the turbine is crucial for the production of electricity. It is achieved by kinetic and potential energy of water. Thus, in hydroelectricity power plants, potential energy of water is converted into the electricity, which we have already discussed. So, electrical generator converts mechanical energy available from hydro turbine into electrical energy by means of electromechanical energy conversion process. Turbine speed governs the design of the generator. The synchronous speed of generator can be estimated by N is equal to 120 F by P, where P is number of poles and F is the frequency of the system. Mainly two types of generators are used in electrical power systems. They are synchronous generators and asynchronous generators. Synchronous generators are equipped with a DC electric or permanent magnet excitation system, which is rotating or static, associated with a voltage regulator to control the output voltage before the generator is connected to the grid. They supply the reactive energy required by the power system when the generator is connected to the grid. Synchronous generators can run isolated from grid and produce power since excitation is not grid dependent. Asynchronous generator are simple squirrel cage induction motors with no possibility of voltage regulation and running at a speed directly related to system frequency. They draw their excitation current from the grid, absorbing reactive energy by their own magnetism. Adding a bank of capacitors can compensate for the absorbed reactive energy in this type. They cannot generate when disconnected from the grid, that means these are dependent on the grid because they are incapable of providing their own excitation current. However, they are used in very small standalone applications as a cheap solution when required quality of electricity supply is not very high. In synchronous generator, speed is kept constant, whereas in asynchronous generator, this speed is varying. Transformers is a static device used to transfer electrical energy from its primary to secondary side by stepping up or stepping down the voltage. Step-up transformers are used at power stations to step up the generated voltage for the purpose of transmitting higher voltage over long distance has many advantages like low power transmission loss, reduction in cable and insulator size, low cost, etc. Step down transformer are used at distribution and to step down the voltage according to requirement of users. Instrument transformers are used to measure high voltage and high current in electrical power systems. Mainly current transformers and voltage transformers are used for this purpose. Circuit breakers. It is a protective device which protects electrical networks from faulty condition. The main purpose of circuit breaker is to isolate the faulty parts from the networks so that fault is being localized. Earlier fuse was used, now it is being replaced by this circuit breakers. Relay is also a protective device which used to sense the abnormal condition in the electrical system. Whenever abnormal condition occurs, relay operates by closing its contacts to give the signal to circuit breaker for opening circuit breaker contacts, thereby fault is isolated. Powerhouse is to protect the electromechanical equipment that converts the potential energy of water to electricity from the weather and provide a place for carrying out operation and maintenance activities. The number, type and power of the generating units, their configuration, the scheme head and topographical condition of the site determine the shape and size of the building. The layout may differ from project to project as per site condition. The powerhouse comprises of machine hall having main hydro generating equipment. turbine, governor and generator. Serviceway to carrying out erection and maintenance activities. Control room having control panels, relay and tail race for water exit. So, the equipments which are placed in the powerhouse building are inlet gate or valve, turbine, speed increaser, generator, control system, condenser, switch gear, protection system, DC emergency supply, power and current transformers. Let us see the classification of hydropower plants. Hydropower plant classification based on the capacity vary from country to country. In India, the classification depending on the capacity is into micro, mini, small, medium and large hydropower plants. Micro is up to and below 100 kilowatt, mini type is up to 2 megawatt, small is up to 25 megawatt, medium is up to 100 megawatt and large is above 100 megawatt. There is another one Pico Hydel plant which is having a capacity less than 5 kilowatt. It is mainly for the individual homes, while the micro Hydel plant that is having less than 100 kilowatt is for the rural community. Mini Hydel plant that is between 100 to 1000 is mainly meant for towns. Small Hydel plants with 1 to 25 megawatt is for small cities. Large Hydel plants are mainly for the large cities which are having the more number of persons or highly or the population is high or densely populated cities. So, the hydropower plants is classified based on the capacity into micro, mini, small, medium and large. It is also classified based on head available into ultra low head which is below 3 meter height, low head which is between 3 to 40 meters, medium head which is between 40 to 75 meters and high head is above 75 meters. It is also classified according to operation and type of flow into 3 categories: runoff river, storage or reservoir type, pumped storage, hydropower plants. In addition to that, Instream technology also one of the category based on the operation and type, which is a new one. So, these hydropower plants vary from very small to very large scale depending on hydrology and topography of the watershed. Based on the direction of flow, the first category is runoff river scheme. These are hydropower schemes in which available water is diverted from stream for hydropower generation. Such a hydropower plant generally includes some short term storage, that is hourly, daily or weekly, allowing for some adaptations to the demand profile. These plants are normally operated as base load power plants. A portion of river water might be diverted to a channel pipeline, which is penstock. We have already seen what is a penstock, to convey the water to hydraulic turbine which is connected to an electricity generator. The installation of this plant is relatively cheap and in general only minor environmental impact is observed under this scheme. The reservoir type. In order to reduce the dependence on the variability of inflow, many hydropower plants comprise reservoirs where the generating stations are located at the dam toe or further downstream through tunnel or pipelines as per electricity or downstream water demand. These are mainly situated in the river valleys. Most of the time these dams are constructed in the river for desired use like irrigation, drinking, flood control, etc. Pumped storage plants pump water into an upper storage basin during off-peak hours using surplus electricity from base load power plants and reverse flow to generate electricity during the daily peak load period. It is considered to be one of the most efficient technologies available for energy storage. The excess electricity in the grid is usually the generation of thermal power plants or other renewable energy source like wind or solar. Instream technology using the existing facilities is to optimize existing facilities like weirs, barrages, canals or falls. Small turbines can be installed for electricity generation. Smaller falls are also available on cooling water, return channels on thermal power stations, drinking water and sewage channel after the treatment. This is basically functioning like a runoff river scheme. Now, what are the factors affecting energy production in a hydropower plant? The potential for energy production in a hydropower plant is determined by amount of water available, water loss due to flood spill, bypass requirements or leakages, the difference in head between upstream intake and downstream outlet, hydraulic losses in water transport due to friction and velocity change, and efficiency in energy conversion of electromechanical equipment. These are dependent on the hydrology, topography and design of power plant. Energy losses occur in the water conductor system from diversion point, that is the intake to turbine, is known as head loss. It reduces the head and hence the energy potential for the power plant is also reduced. These losses are classified either as friction loss or singular losses. Friction losses depend mainly on water velocity and the roughness in tunnels, pipelines and penstocks. The total efficiency of a hydropower plant is determined by the sum of the three loss components. These losses can be reduced. Hydraulic losses can be reduced by increasing the turbine capacity or by increasing the reservoir capacity to get better regulation of the flow. Head losses can be reduced by increasing area of head race and tail race, by decreasing the roughness in these and by avoiding too many changes in flow velocity and direction. Different turbine types have quite different efficiency profiles when the turbine discharge deviates from the optimal value. The benefits of hydropower. Hydropower is a renewable energy source. This power has among the best conversion efficiency of all the non-energy source of renewable category. It has about 90% efficiency. Hydro storage capacity can mitigate freshwater scarcity by providing security during lean flows and drought for drinking water supply, irrigation, flood control and navigation services apart from the energy production. These plants do not consume the water that drives the turbine. So, the water after power generation is also available for various other essential use. It can serve both in large centralized and small isolated grids and small scale hydropower and is an option for rural electrification. So, it is a clean fuel, it is fueled by water and it is not producing any other toxic products. The small projects have potential to meet power requirements of remote and isolated areas, and we have seen that it conserves the fossil fuel. It is a substitute to thermal power plants, thereby reducing the carbon emissions since this works on the water. Hydropower relies on the water cycle which is driven by the sun, and so it is a renewable power source and as a clean fuel energy source. Hydropower is generally available as needed. It is possible only when engineers control the flow of water through the turbines to produce electricity on demand. It provides benefits in addition to clean electricity like water supply, flood control, and also offer a variety of recreational activities like fishing, swimming and boating. It requires relatively high initial investment but long lifespan with very low operation and maintenance cost are the advantages of hydropower. But the disadvantages are it is harmful to riparian, that is riverbank habitats. Hydropower plants are impacted by drought, that means no water, then no electricity production or less electricity production. New hydropower facilities impact local environment, it compete with other uses for the land. Human flora and fauna lose their habitat and also settlement is required in some cases. The local cultures and historical sites also get damaged are some of the negative impacts of hydropower plants. To conclude, hydropower is the energy produced from moving water. It is produced from the water in motion by rotating the turbine, in turn rotating the generator, producing electricity. In this process, kinetic energy converted to mechanical energy, further converted to electrical energy. We have seen the hydropower potential, how to estimate hydropower potential. The hydropower P is equal to QH multiplied by 9.81 eta. We have seen different components of hydropower plant. Civil components, hydro-mechanical equipments and hydroelectric equipments. In this, dam, reservoir, penstock, turbine, generator, etc. are the most important components. We have classified the hydropower plant based on the capacity into mini, micro, small, large, etc. And also we classify it based on the head, like ultra head, which is having a head or the height of less than 3 meter, very low, which is having 3 to 40. Then we have seen the large ones which are having greater than 75 meter. We have also seen the classification based on the, according to the operation or the flow of water, like runoff river, storage or reservoir type, or the pumped storage type. Also we have seen a new one, Instream technology, for the harnessing of the hydropower energy or hydropower. We have seen the benefits of hydropower as a renewable energy source, and mainly the water which is used to run the turbine can also be used for the other purposes, since it is not lost, and it is considered as a clean fuel. But it has some disadvantages, like it loses or it creates negative impacts on the riparian habitat. It may lead to the settlements. Thank you.